Okay, sir.
Yes, sir.
So cement and concrete cement materials. Generally, we know that these are used for construction of habitats. That means houses, dams, projects. So we are using these building materials. So here the building materials which may use it for construction purpose. Many of these materials they are occur in nature by naturally. So some of the substances occurring in the nature by naturally. So the substances are clay, rocks, sand, and wood. So how utilizing these components to making the building construction materials. So many number of manufacturing companies, construction buildings, building materials. So the industries were established in many countries. They provide these building materials to use it to construct various structures, whatever it may be we want. We can construct by using these type of building materials. So generally, the finely powdered mixture of calcium silicate and calcium aluminate is called cement. So what is meant by cement means? So this a finely powdered mixture of calcium silicate and calcium aluminate. So this mixture is known as cement. So it has the property of setting to hard in solid structure. While mixing these two mixtures with the help of using water, so which forms a slurry, so that's how the great property is setting to a hard solid structure. So that is cement. So next here classification of cement. So classification of cement classified into based upon their composition of components present in the cement. The cements can be classified into 5 types. So one is a natural cement, second one slag cement, third one Fazlona cement, fourth one high alumina cement, so fifth one Portland cement. So based upon the composition of the components present in the cement, cement can be classified into various types. So let's see the first one, natural cement. So natural cement is obtained by naturally occurring limestone. So natural cement which is obtained by naturally occurring limestone, calcium oxide, sunnopride. So natural occurring limestone, so which containing 20 to 40% of clay. Natural cement, they may containing 20 to 40% of clay. So at a high temperature, so and subsequently the formation of powder, that means mass of the limestone. they having that means the limestone which converted into powder which require high temperature. So during heating, silica and alumina present in the clay reacts with the lime to produce calcium silicate and calcium aluminate. So this mixture of calcium silicate and calcium aluminate which gives natural cement. So this natural cement may having a rapid setting and possess a low strength, which possess low strength and rapid setting. So what is the composition of natural cement means? So calcium silicate and calcium aluminate. So these are the components present in the limestone. So when we applying higher temperature and heat, so these components present in the clay react with the limestone to gives the calcium silicate and calcium aluminate. So that is the natural cement. So natural cement is a naturally occurring limestone. So which is having 20 to 40% of clay. So that clay which converts to cement when we apply heat and high temperature. The clay containing silica which react with the limestone and forms calcium silicate. The clay containing aluminium which react with limestone to gives calcium aluminate. So these two mixtures are known as natural cement. So next we go for a slag cement. So what is meant by slag cement? So slag cement is also produced by mixing of blast furnace slag and hydrated lime and with grinding with a small quantity of gypsum. So slag cement sets very slowly and has low strength. So listen Anna, slag cement is the mixture of slag and hydrated lime. So hydrated lime, slag, we go for grinding process and we added some quantity of gypsum. So the formation of powder is known as slag cement. So the slag cement may having the low strength. Next, Fazzola cement. So this Fazzola cement may obtain by mixing Fazzola. So what is meant by Fazzola? So Fazzola means deposits of volcanic ash. So Fazzola means deposit of volcanic ash is known as Fazzola. So and slaked lime. So slaked lime just like a stone. The stone we are using for writing purpose that is known as slate. Slate. So Sajlona slaked rack and volcanic ash will mixing to manufacturing the Fazlona cement. So in this Fazlona cement, they having a property that is a hardening property is a very slow. Now what is the mixture of Fazlona cement means slag plus Fazlona and slaked lime. So Fazlona means volcanic ash, slaked lime means so just like a rock. So that rock we can use it for slates. Writing slates is known as manufacturing from the slaked lime. So that is a slaked lime rock and volcanic ash used to manufacturing the Fazlona cement. So next we see the high alumina cement. So this is the mainly they having calcium aluminate and by preparing by using the limestone and bauxite. So by using the calcium aluminate, limestone and bauxite we maintaining the 1550 to 1600 degrees Celsius temperature. So in that temperature, we get the mixture of finely powders. So that finely powder mixture is known as high alumina cement. So which is having a rapid rate of development of strength and has a superior resistance to sea and sulfate waters. So listen, Anna, high alumina cement we can manufacturing by using the calcium aluminate, limestone and bauxite at higher temperatures. So what is the temperature? 1550 to 1600 degrees Celsius temperature we use for mixing of calcium aluminate, limestone and bauxite. We get the high alumina cement. So next, fourth, last one. So Portland cement. So Portland cement is produced by mixture of calcareous matter which containing lime and argillaceous matter which containing clay. So the mixture of lime and clay used to we make a powder. So that powder will added addition of 2 to 3% of gypsum, that is known as Portland cement. So how to making Portland cement? We use the mixtures limestone and clay and addition of 2 to 3% gypsum we added to make a finely powder is known as Portland cement. So this Portland cement, one of the scientists discovered in the year 1824. So Joseph Aspdin of England scientist, they discovered the Portland cement in 1824. So this has a quick setting and a hardening property when made into the paste with sand and water. So listen, Nana. Portland cement is the mixture of lime and clay and addition of 2 to 3% gypsum. We using these three combinations to mix and form a powder. So that is known as Portland cement. This Portland cement was discovered Joseph Aspdin as England scientist in the year 1824. So this cement may having quick setting and hardening property when made it a paste with sand and water. So that is the Portland cement. So next we go for chemical constituents of Portland cements. That means what are the chemicals are present in the cement and their average percentage. So let's see the name of constituents, chemical formula and average percentage. So let's see now. Tricalcium silicate. Tricalcium silicate. That means chemical formula having 3CaO SiO2. So this is known as tricalcium silicate, or generally these tricalcium silicate we express as C3S. So C3 means tricalcium, S means silicate. So these having the composition in the cement, so that is 45% of tricalcium silicate which is present in the Portland cement. So next we see the second one, dicalcium silicate. So dicalcium silicate. So that is 2CaO, 2 moles of calcium oxide and silicon dioxide. So calcium oxide and silicon dioxide in the 2 mole of calcium dioxide silicon dioxide. So we known as the dicalcium silicate. So this is the chemical formula, and we express this C2S. So this having 25%, which is present in the cement. So next one, tricalcium aluminate. Tricalcium aluminate. So that is 3CaO.Al2O3. So which expresses the formula C3A. So calcium aluminate. So these may having only 1% present in the Portland cement. So next we go for a tetracalcium aluminoferrate. Tetracalcium aluminoferrate. So this is a chemical formula 4CaO aluminum Al2 trioxide. So Fu2O3 iron trioxide, or which is expressed in the formula C4AF calcium aluminoferrate. So these component which may having the average 9%, which is present in the Portland cement. So next we see the calcium oxide CaO. So the average percentage 2% will present in the Portland cement. Next we see the calcium sulfate. So that is calcium sulfate formula CaSO4, which is present in the 5%, average 5% of calcium sulfate present in the Portland cement. So next, magnesium oxide MgO, the chemical formula, which is present in the Portland cement. The average percentage is 4%. So these are the components present in the composition of Portland cement. So next we go for manufacturing of Portland cement. So here manufacturing of Portland cement, that means how to make Portland cement by using the lime and clay. So that is lime means calcareous matter, clay means argillaceous matter. So by using the argillaceous matter and calcareous matter and added addition of 2%, 2 to 3% gypsum to make the Portland cement. So let's see what are the raw materials we used in the manufacturing of Portland cement. So here we use some of the components used as raw materials for manufacturing of Portland cement. So let's see the raw materials. So we are using manufacturing of Portland cement. So let's see. So first one, calcareous matter. Calcareous matter, that means lime. So for examples, in the calcareous matter, we are using the limestone, chalk and marble. So these are the materials which are present in the calcareous matter. So second one, we require clay materials. So clay materials, that means argillaceous materials. So here we using the clay, shale and slate. Shale means which is a one of the type of rock material used for the manufacturing of Portland cement. Slate means so which is a rock we are using for writing slates. So slate, which is a rock we use it to manufacturing writing slates. So these shale and slate may having enriched sources of silica and alumina. So these are the two components may having the enriched sources of silica and alumina. Next one, powdered coal or fuel oil. So finally powdered coal or we require fuel oil as a raw material for manufacturing of Portland cement. So finally we require gypsum. So calcium sulfate dot 2H2O. So this is the formula of gypsum. Additionally, we added 2 to 3% of gypsum while manufacturing the Portland cement. So next, we see the manufacturing of Portland cement. So what are the steps involved? So here, while manufacturing the Portland cement, so these are the simply 4 steps are involving. So what are they? We discuss one by one. So let's see the first one. So that is mixing of raw materials. In the first step itself, we mixing the what are the raw materials we required for manufacturing of Portland cement. So that is mixing process. The first step is mixing of raw materials. So next, second step, which is insert burning. So after mixing the raw materials, which goes to the burning. Second step in the burning. So after burning, third step, we go for grinding. So fourth step is storage and packing. So these are the 4 steps which are involving in manufacturing of Portland cement. So let's see here mixing of raw materials. So first one, mixing of raw materials. So here the mixing of raw materials for the manufacturing of cement is done in 2 methods. So mixing of raw materials is a major method. So in this major method, we are using 2 processes for mixing the raw materials in the mixing of raw materials. So one is dry process and the second one is wet process. So these are the 2 process, dry and wet process. So we use for mixing of raw materials while manufacturing the Portland cement, which is a first step. So let's see the first one, dry process. So what is meant by dry process? So in the dry process, both lime and clay raw materials are firstly crushed. So whatever it may be, we used the raw materials for manufacturing Portland cement as a calcareous matter and argillaceous matter. So calcareous matter means lime, argillaceous matter means clay. So these 2 components are freshly crushed. So that is firstly crushed, then mixing. So that is a lime and clay are separately crushed by using various grinders. So rotaries, so rotary cursors, we use it to mix formation of fine powders in separately. So after that, the crushed materials are again grinded to get fine particles into ball mill or tube mill. So ball mill or tube mill, so which is used to again grinding the raw materials, that is lime and clay raw materials. Again, we grinding in the using of ball mill instrument or tube mill instruments. So next we see the now these 2 materials were mixed in the required portions to get a dry raw mixture. So we separately crushing and we get the powder separately. Lime is separately, clay is separately, we prepare the mixtures. So after preparation of these mixtures, we added. So these raw materials of two powder mixtures are added. So then stored in the soil and kept ready to be set into the rotary kiln. So rotary kiln means, so which is used, rotary kiln. So that is known as rotary batti. So just like bricks batti. So that is the one of the, here we are using making of setting and hardening of bricks. We are using the bricks batti, bricks kiln. So here we are using the kiln for hardening and setting of these finely powder mixtures in the dry process. So next we go for wet process. So in the wet process also, so limestone is firstly crushed and make into the powder and stored in the soils. Similarly, clay is then washed with water to remove the organic matters. So wet process, wet means we are using the water, moisture. So that's why firstly we prepare the limestone powder and we stored in the soil. So after that we using the clay, which is then washed with water to remove organic matter present in the clay. So after that what will we do? The produced or powder limestone and water, that means water washed clay, are transferred to grinding mills. You know, firstly we prepare limestone powder. So after that clay is washed with water for removal of organic components. So after that we mix the powder and water washed clay and transport to the grinding mills where they are completely mixed and we make the paste. So that paste is called wet slurry. The wet slurry containing 38 to 40% of water. So that is stored in the tanks and kept ready for the rotary kiln. So this is the process to making the slurry in the wet process. So next, burning of raw materials. So what are the materials we used? So that is limestone and clay. So making the limestone and clay or powder mixtures in the dry process, we get slurry in the wet process. So after we getting two process, two components, so it's slurry one and a dry mixture one component. So these components are further in the second step we are going to be used burning. So burning of raw materials is carried out in the rotary kiln, so which is a steel cylinder and having inside the refractory bricks. So that is kiln we use it for burning of these slurry and dry mixtures. So this kiln is laid in the slightly insulated position towards to the lower end. So the raw mixture of dry powder process and wet slurry or wet process we are getting are injected into the kiln from the upper end. The kiln is heated with the help of fodder coal. So initially we say we require the fodder coal or fuel oil. So which is used for heating in the second step. So hot gases forms the lower end of the kiln, so that the long hot flame is produced. So the following reactions are takes place in the rotary kiln. So here we see the one of the simple setup we are using for burning process. So here we insert the slurry or dry powder of two mixtures. So in this, initially we are using 400 degrees Celsius temperature. So this is a cylindrical tower which is called as a kiln. So here we introduce hot air to the kiln. So for here we introduce the air for cooling of clinker when which is finally converted as a powder at high temperatures. Initially we say the Portland cement manufacturing, we require the temperature is 1550 degrees Celsius to 1600 degrees Celsius temperature. So at this temperature, the two mixtures, that means we are preparing dry process mixture and wet process mixtures, which process at high temperatures.
Sir.
After the
Hello, sir.
Chepma Kiran Nana చెప్పండి కిరణ్
సార్ చెప్పండి సార్
ఏమ్మా చెప్తున్నానా
నేను కాదు సార్ వెంకటేష్ సార్ అడిగేది
ఏమంటమ్మా ఏనన్నా డౌట్ వెంకటేష్
సార్ మీరు చెప్పండి సార్ క్లాస్ చెప్పండి సార్
నానా కిరణ్
చెప్పండి సార్
29 నెంబర్స్ ఉన్నారు కదమ్మా ఇప్పుడు తీసుకున్నా నా స్నాప్
సార్ 30 మెంబర్స్ తీసుకున్నాను సార్ 30 మెంబర్స్ ఉన్నప్పుడు తీసుకున్నాను సార్ స్లాబ్
ఓకే నాన్న ప్లీజ్ మ్యూట్ యువర్ మైక్స్ సో we having this simple setup, so which is called as a kiln means rotary batti antamana. This is known as in Telugu rotary batti. So manaki itkil batti untadi chusara, same alagane which is made up of kiln as a rotary batti. So here we introduce dry mixture powder or wet process, we are making the slurry. So here initially we maintaining 400 degrees Celsius. So after the mixture passes through the center of the kiln, we maintaining 1000 degrees Celsius as a temperature. So finally, so bottom of the kiln we maintaining 1500 to 1700 degrees Celsius as a temperature. On the other hand, we introduce hot air to the kiln. So here the formation of fine powder, so which is coming to the storage point as a cold clinker. Here we using the air for a cooling clinker. So when this cold clinker again passes through the ball mill, while passing through the cold clinker to the ball mill, we added 2 to 3% of gypsum. So finally we get the cement. So once again listen Nana. So this is a small setup of kiln. So here we introduce the slurry or a dry process, we are making the powders. Initially we maintain 400 degrees Celsius. Further we increase the temperature to 1000 degrees Celsius. So further process. So here we maintaining 1500 to 700 degrees Celsius as temperature. In additionally we added some hot air to this kiln. So here at a high temperature, the formation of fine mixture will come to this chamber. Here we adding the cool air for cooling clinker. So the cold clinker when passes to the ball mill for mixing, here we adding the gypsum. So finally we get cement. So ball mill or tube mill will use it to mix the mixers uniformly. So that's why we adding the gypsum when passes through the ball mill. So coming to the drying zones, we clearly explain what about at 400 degrees Celsius, what are the reactions takes place, what are the clinkers are formed, and at 1000 degrees Celsius, what are the components are formed, and 1500 to 1700 degrees Celsius, what are the components are formed. So we clearly explain in the drying zones now. So here the first one, drying zone. So after we getting the cement, so the upper part of the kiln, that means this is the upper part of the kiln where the temperature is only 400 degrees Celsius. Here we using the 400 degrees Celsius as a temperature, and the slurry gets dried. So here, for example, we are taking the wet process. In the wet process, we are prepared a combination of two components, that is lime and clay. We prepare the slurry. So that slurry, we introduce the bottom of the kiln, the bottom, sorry, top of the kiln. So in the top of the kiln, we are maintaining 400 degrees Celsius as a temperature. So that slurry get dried in this temperature. So most of the water which is present in the slurry, we maintaining 400 degrees Celsius temperature, the water get evaporated now. So next, coming to the calcination zone. So this is the second step. We are maintaining 1000 degrees Celsius as a temperature. So that is known as calcination zone. So it is the central part of the kiln. So we are maintaining 1000 degrees Celsius as a temperature, which is the center part of the kiln. Here, where the temperature is 1000 degrees Celsius, limestone of dry mixture or slurry undergoes decomposition to form a quick lime and carbon dioxide. Here, so that is in the center of the kiln, we are using 1000 degrees Celsius temperature. In this 1000 degrees Celsius temperatures, so slurry or dry components undergoes decomposition. Here in this center of the kiln, the slurry or dry components undergoes decomposition and they form the quick lime and carbon dioxide. So that is calcium carbonate undergoes decomposition to forms calcium oxide and carbon dioxide. So let's see the equation. Here calcium carbonate undergoes decomposition at 1000 degrees Celsius temperature. At the center part of the kiln, we get the calcium oxide and carbon dioxide. Next, clinkering zone, next step. So the lower part of the kiln, we are using the higher temperature, already we discussed. So here, this is the bottom of the kiln. So in this lower part or bottom of the kiln, we are using 1500 to 1700 degrees Celsius. We maintaining the temperature where lime and clay are react with to give yield. That is the product. Yield means product calcium aluminate and calcium silicates. So here, after at the center part of the Kelvin, we get only calcium oxide. So this calcium oxide, further temperature we increases at 1500 to 1700 degrees Celsius temperature. So in these temperatures, the lime and clay are react with to give yield. So what is the yield means? Calcium aluminate and calcium silicates. So the aluminates and the silicates of calcium fuse together to form a hard greenish stone called clinkers. So here at 1500 to 700 degrees Celsius, clay and lime react with to form the calcium aluminate and calcium silicates. So these two components having aluminate and silicates. So that's why calcium fuse together to form a hard greenish stone called clinkers. So here the formation of components which exist to the ball mill. So this component after completion of reaction, they produce the products. So that products are exist in this way. So here we using the air for cooling of formation of the clinker product. So the here the product formed is known as clinker. So clinker means shiladhravamunana. So when we use it heat and while applying the heat, some of the components are get burning and some will be elevated. So that elevated component is known as the clinkers. Here, while burning of lime and clay, they produce one product. So that product is known as the clinker. So where the burning takes place, so after burning, they gives the product is known as clinker. So we are using high temperatures. That's why the clinker has a very rapid heat. So that's why we applying in addition of cool air to the formation of clinker. So finally we get the cold clinker. So this cold clinker we added 1 to 2% of gypsum and which passes to the ball mill. So ball mill will use it to mixing the formation of the clinker. So after uniform mixing, when we added gypsum to the clinker, so we get the cement. It's in the clinkering zone. So let's see the clinkering zone. So what are the reactions here? So we are getting calcium oxide. Where we get calcium oxide? So at the 1000 degrees Celsius temperature, the components undergoes decomposition. Calcium carbonate undergoes decomposition, which gives calcium oxide and calcium oxide and carbon dioxide in this equation. Where this here calcium carbonate undergoes decomposition at 1000 degrees Celsius temperature, we get calcium oxide plus carbon dioxide. So coming to here, clinkering zone, calcium oxide plus silicon dioxide react with to give dicalcium silicates. So generally, initially we discussed the chemical composition and percentage of components present in the Portland cement. The first one is dicalcium silicates. So which is a 45% average, which is present in the Portland cement. So next, tricalcium calcium oxide and silicon dioxide, which gives tricalcium silicates. So calcium oxide and silicon dioxide at 1500 to 1700 degrees Celsius temperature, they combine with to give tricalcium silicates, which is a 25% average percentage present in the Portland cement. So after calcium oxide react with aluminum trioxide, which gives tricalcium aluminate. So tricalcium aluminate, which is having only 1% average percentage, which is in the Portland cement. Anna?
Sir.
Chipma? Kiran? Niranjan?
సార్ B3 బిడి క్లాస్ స్టార్ట్ అయింది సార్.
అయితే డిస్కస్ చేస్తామా, రేపు కంటిన్యూ చేస్తాం నాన్న.
ఇక్కడ దాకా చెప్పారు కదా సార్, గ్రైండింగ్ పైన దాకా చెప్పారు, రేపు కంటిన్యూ చేద్దాం సార్.
మళ్ళీ ఇక్కడ క్లింకరింగ్ జోన్ నుంచి మళ్ళీ చెప్తాలేమా రేపు. ఈక్వేషన్స్ కానించి మళ్ళీ స్టార్ట్ చేస్తాం.
ఓకే సార్.
ఓకే బాయ్ మా. నిరంజన్
అటెండెన్స్.
నిరంజన్
సరే సార్, అటెండెన్స్ పంపించేసా సార్.
ఓకే
అటెండెన్స్ పంపేసా సార్, మీకు
రైట్
పంపించేసా సార్ అటెండెన్స్ 30 మెంబర్స్.
ఓకే మా.
ఓకే సార్, థాంక్యూ.
ఓకే బాయ్ సార్. ఏమైనా డౌట్స్ ఉంటే నెక్స్ట్ క్లాస్ లో స్టార్టింగ్ అడగండి.
సరే సార్, ఖచ్చితంగా.
ఓకే మా.
నిరంజన్ నెక్స్ట్ క్లాస్ ఏంది?
నెక్స్ట్ క్లాస్ B111.